In this lecture, we discuss Vertex shader applications and revisit the simple Vertex shader program. So what are applications of Vertex shaders? This is the pipeline that we have been discussing so far. The Vertex shader is here, which takes input from the application program and passes it down the pipeline until it reaches the fragment shader and the pixels come out. Geometric transformations, that is changing the relative location, the rotation and scale of objects and camera, are performed in the Vertex shader. Apply 3D perspective transformations, which makes far objects smaller, is also performed inside the Vertex shader. Moving of vertices is also performed inside the Vertex shader. This is called morphing. So once you move the vertices of an object, it morphs to a different object. For example, computing a wave motion and deformations due to physical forces, this all can be performed inside the Vertex shader. Or simulating particle effects for fire, smoke and rain or waterfalls can also be performed inside the Vertex shader. Computation of fractals can also be performed inside the Vertex shader. Continuing with the applications of the Vertex shader, lighting effects can also be performed inside the Vertex shader. The Vertex shader performs per vertex lighting calculations, such as calculating shading color using light and surface properties, how different lights will interact with different surface properties to produce different colors. Calculation of cartoonish type of shading for special effects can also be performed inside the Vertex shader. In the rendering pipeline, each vertex is processed independently. This is called per vertex calculations. The Vertex shader basically processes one vertex at a time. It takes in one vertex from the vertex stream as input and generates the transformed vertex, optionally with the attributes, to the output vertex stream. Shaders are small programs that are compiled and run on GPUs. Multiple shader programs can be invoked and run in parallel to render complex scenes in real time. Here we are revisiting the simple Vertex shader that we studied before. The first line, which just specifies that it should use GLSL version 1.5 for compatibility. In here means the input from the application program. Vertex 4 is a data type and vPosition must link to variable in the application. This is where the main GLSL program starts. And in this program we are simply assigning the vertex positions to the inbuilt variable GL position. This GLSL program is for Linux and Windows.